Okay, Jeff, it's all yours.
All right, thank you. First of all, thank you very much for inviting me to talk tonight. I'm going to take many breaks as I'm presenting here and encourage you guys just to jump in with questions. In fact, if I'm covering something you're like, I'm not quite understanding that, just immediately flag me down and stop me where I'm at right there, because there's nothing more frustrating than to have somebody blab on for another 20 minutes and you're like, but I didn't get the first part you were talking about. So I want to make sure that you guys get a lot out of this presentation today. Quick question I'll ask in the first here. How many of you guys have actually used WINLINK? How many people have played around with it? It's a pretty good number of people right there, which is good. And this guy gets on it big time right there. Of those that have used WINLINK, how many of you guys have used Pactor modems? Yeah, one person right here. So a few more people like that. So, of those of you that have used WINLINK, how many of you have done it on HF? Fair number of people. How many of you have done it on VHF or UHF? Okay, got a few people here. So, point being is, does anybody know when WINLINK started?
Yes.
Yeah. In the beginning. In the beginning, there's WINLINK. It's given away by the first name that they actually came up with it, which was WINLINK 2000. So around the turn of the century, which when I say that, people are like, Jeff, don't say it that way. It makes me feel old. But it's been around for over 20 years now. A lot of people are just now hearing about it, but it actually started very humble beginnings, and it was mainly using packet radio, and Pactor modems was kind of the beginning start of how WINLINK got started. And it looked very similar to this, but it wasn't nearly as nice because we were a few versions of Windows ago, so the menus weren't as pretty, the colors weren't, all this type of stuff. But this is pretty much what it looked like. And the big selling point when they first created it was it's got an email interface. We all work with email, either Outlook or the client of your choice, and this, makes it easy to use. That's half of the equation. As far as the system is concerned, and that is, how do you send messages, how do you receive them, all that type of stuff. But the other half of it that I'll talk more about today is how you actually get those messages off of this to somebody else. And that's the modem part of it, the modulator, demodulator part of it. Like I said, in the early days of this, it started out on packet radio, it started out on Pactor modems, and you put it up on HF, connect to your friend, and then talk about how between the two of you, you'd spent $2,000 on your Pactor modems and that you felt very great about that. Just so you could send emails to somebody. But that's kind of the humble beginnings of when it started. And it was rather limited. Not a lot of people were running around with Pactor modems. And in fact, it was funny. I met a guy down in Texas one time. He's like, I have 4 Pactor modems. I was like, and how many houses do you own too, sir? It's like, it's a indication of investment when you have that many Pactor modems. But that's kind of how it started out. And one of the big barriers to getting onto HF was Pactor. It's like, no, I don't want to drop $2,000 to get on HF. So a few of us back then who were very naive and thought it was a great idea said, sure, we'll use packet on HF. It will be great. And of course, the guys that are sitting with Pactor modems are just sitting there on, yeah, right, good luck on that whole thing. And I can tell you, the entire time that I connected to the gateway station up in Colorado over a 2-year time period back in the early 2000s, I was able to connect once in those 2 years successfully. Not a really effective system. It was like, oh yeah, HF packet, not quite up to the gear to do this whole thing. But about 2005, 2006 time frame, a bunch of guys got together and said, hey, packet TNCs, hardware solutions, that's kind of the past way of doing things, and sound cards are getting pretty good on computers. So let's come up with something that's Windows-based and replaces Pactor, hence WinMore is what they called it. And so they came up with what was called the WinMore modem. I'd say it was about 60 to 70% of what a Pactor modem could do. There was definitely limitations in terms of signal-noise ratio, definitely limitations in terms of speed, but it also was free. So free is always nice. Free always beats, $1,200. So WinMore became a sound card modem that everybody started using, and myself included. We'd get up on there and send messages back and forth, and it was a very inexpensive way to work. Right after WinMore was developed, some gentlemen got together with what I would call a very good idea, but it didn't really take off, and it was called RDOP. It was supposed to be a cross-functional modem that was supposed to be able to be used on any platform, Macintosh, Linux, Windows, you name it and everything. There's only one problem in that whole equation, and that is the WINLINK software only runs on Windows. So you could put this modem on another computer, have it over here, and then go to your Windows computer to use it. And that's where a lot of people were like, why are we doing this? So RDOP really never took off like it was supposed to. I actually was one of the first RDOP adopters here in the area, had it up on my system, and I had like 3 guys that would connect to it on a regular basis, and even they were starting to say, why are we doing this type thing? Well, about that time that had been out for several years, and that was supposed to be the next generation that was supposed to take over for WinMore, a gentleman over in the European community who has a lot of knowledge of military radio, a real great knowledge base, Jose, sat there and developed what was called VARA. And the idea behind it was most of your modems prior to this, like for example, if you look at your packet modem, it's a 2-tone modem. If you look at many of the other modems, they're either single carrier. If you look at PSK31, how many carriers are there on PSK31? 1 carrier. So most modems run single carrier, which, by the way, if you read the FCC regulations, we're limited to what data rate on the 2-meter band if you have a single carrier? 1200 baud. What are you limited to on UHF? 9600 baud. And what are you limited to on the HF bands? 300 baud. So Jose says, why don't we do multiple carriers? And so he actually came up with a scheme that has, I think, as many as 24 or 28 carriers all working in the same audio bandwidth. And by doing so, he was able to achieve some pretty incredible data rates on HF. His top speed on HF is right around 6,000 baud. So it blows right along and just blows and goes, and you make the connection and do a lot of stuff there.
How much bandwidth?
Uses 2.3 kilohertz, so 2300 hertz, which is about what your voice bandwidth is, plus or minus.
3 times.
Exactly. So you can expand a lot more through the system. So he developed a system called VARA. Many of us started testing it and we're having really good success with it on HF. And it was a really great system he put together. And then myself and a ham over in the Sapulpa area said, well, and this other ham didn't do a lot of HF stuff. He goes, what do you think if we put it on VHF, how it would perform? Well, on HF, if you had band fading, things like that, the data rates would go up and down depending upon band conditions. So we ran it 2-meter simplex first, and then we actually ran it later on a 2-meter repeater, and boom, it was always maximum speed all the time. So we communicated this back to the author of it, and he's like, well, shoot. He says, you realize your bandwidth is much wider on VHF than what you have on an HF signal. And I thought, yeah, that's true. Yeah. And about 3 weeks later, he came up with VaraFM and says, I'm going to use that entire bandwidth, and I'm really going to superimpose the carriers on it, and let's give this a shot. Now, mind you, most of us that had experience on packet radio, what did we say the maximum speed was on VHF? 1200 baud. So we're like, oh, if this thing can do 1200 baud, this is going to be incredible. Maybe if it can do even a little bit faster, that'll be great. Straight out of the box, the first time that he ever put it out there, it did 5,000 baud. And it was like, whoa, this thing's flying along here in the whole thing. And it was like, I can't believe that. That's pretty incredible. And he goes, well, give me a few more weekends. The next version he comes out with was 11,000 baud. And it was like, holy cow, you are really doing good on this whole thing. So VaraFM was born. A lot of us played around with it and made connections back and forth. And as you can imagine, if you're sending a message, if you're sending it over HF, you know, you're limited on how much you can attach, file attachments, things like that. You start getting up to 11,000 baud, and you can send pretty big file attachments with your messages. So we would sometimes send 40,000 character messages, which if you did in the old day on 1200 baud, Merlin would have a stroke literally on the spot, because 2 days later you'd finally unkey the digipeater, sending your long message across there. So all of a sudden VaraFM was born. And then Jose, not to be let down again, says, hey, you know, they got those 6-pin adapters on the back of the radios. Yeah, they do. And those are for, and there's a pin on there for 9600 baud, and nobody's using 9600 baud because, you know, it's so hard to get modems and all this other stuff. But I wonder if we use that extended bandwidth, where we go to. And he got to 25,100 baud uncompressed and 50,000 baud compressed. That screams. And so it's been a tremendous move forward to go from the early days of this and kind of see as it's progressed along. And so all of a sudden now, where we used to talk about WinLink Express strictly on the HF bands, strictly on packet, small messages and everything else, we're sending 100K and 200K messages back and forth, and it takes just a few minutes to do it. And so, you know, it's kind of fun to play with. So a little bit of show and tell here today. This is the VaraFM client itself. I don't have it, you know, connected to a radio or anything like this, but over on the right-hand side, you can actually see the waterfall display, see what's going on over your radio, kind of get an idea what type of job it's doing over the air. And if you go into the settings, basically, it's really easy to set up. You basically tell it which port's connected to it, which connects it to the software. In my case, I've configured it for wide because this normally plugs into a 9600 baud connector on the back of the radio. And then there is a license registration, which I'll tell you right now, the people that gripe about the license registration really do need to find something else to gripe about, because it's $69. I mean, really, 69 bucks compared to 1,200 bucks for a Pactor modem. It's a heck of a deal. He talks about on here, VaraFM wide needs an FM rig set for 9600 baud packet. He talks about which boards actually work, how you connect it to your 6-pin. You'll notice the red box around data out 9600 BPS. That's where you connect to. And then if you can't do this, you can still run VaraFM narrow, which, by the way, that goes up to 11,000 baud. So there's a lot of people that run narrow. It's great, it's fun, what have you. Not everybody has to live on the wild side there. Go ahead.
The software cross-platform compatible?
No, it is Windows only. And yeah, it's one of those deals right there. Now, what I can tell you is this software, the Vara software and WinLink, people have successfully run it either if they're running a virtual host on their system. So in other words, a Linux host running a virtual environment they've had good success with. Running Wine on Linux, I've done it where I've pulled it up on Wine and it's worked very well under Wine. A few things you have to configure just to get it to work well right there. The reason why he did this on Windows was, number one, the WinLink software was on Windows, so he didn't see any reason to make it cross-platform. But some of the digital signal processing libraries that he's got built into it refer to libraries that are only Windows-based and are not available in the other platforms. So it'd be a major refactoring of the code for him to get to making it cross-platform. And in fact, he kind of learned from, you know, the software FLDigi, which is cross-platform. There's an incredible amount of programming that's done in that package to make it cross-platform, to make the timing work and everything else. And he kind of looked at that and said, well, there's only one of me right now, so he decided not to make it cross-platform. But that's the only thing I would say is a real downside is, yeah, it's Windows only type thing. I'd prefer to have a Linux version of the whole thing, but that's not the case right now today.
You say it works okay under Wine?
Yes. Yeah. So those are your settings. Then you go in and actually set up your sound card, which in my case is just the computer sound card because I don't have my sound card interface connected into here. The great thing about it that he did was he built into this, and I hope this doesn't hurt people's ears when I hit it here, he built in a tune. So you can actually set your audio level just by listening. Typically what I do is I pull out a handy talkie, set it next to my radio, and you can kind of get the output in the range where it needs to be, where it's not overdriving, because if you guys ever heard a clip signal, you know what that's all about, and if it's underdriving, you definitely know that it's too quiet. So there's a tune, but then he built into it an auto tune, which won't do anything here because we're not connected to a radio, but if I say start calibration, if you listen to it, it's actually trying different audio drives. And if it was on a radio, AE5ME-13 would talk back to it and say, Yes, that one right there is the exact setting you want to stay to. So you can actually self-calibrate your audio levels on it, which is really nice versus trying to do it by ear and figure it out and everything, because that used to be quite a bit of a time that we'd spend setting it up. There's a ping command, and you notice it's got a VIA built into it, which is analogous to what we used to do in packet radio with digipeaters. There's a digipeater function built into this, so you can actually connect to another station via another station in between. But the idea is I can ping that other station, see what my signal quality is, and get it to report back. Really, really nice software package there. You can view your gauges diagram like I want to, or you can make it gauges only if you really want to make it small. It keeps a log of what's going on. And depending upon which sound card interface you're doing, I was running an RA board, you can actually set up what type of push to talk that it's actually going to use. So you can say, hey, let's use CAT, which is you talking to the radio saying here, push to talk via the commands that go to it. Or you can say through a COM port, which is pretty available on a lot of sound card interfaces. The RA board, which I'll talk about in a second. Or you can say Vox. If you're using a signal link, it's Vox. So you'll just go through and say Vox. Don't hit any push to talk. That being said, there's been lots of discussion about how do I get started. How many people here have never done sound card interfaces with their radios and played around with that side of the business? Anybody? So we got a fair number of people that have never done this. If you have a radio that has a sound card already built into it, which many of the modern HF rigs do, so if you've got like an ICOM 7300, Yaesu FT991A, I'm trying to think of some of the other HF rigs that have it there, but if you already have a sound card interface built into the radio itself, then it's as simple as plugging your USB cable into your computer, and you'll actually see the sound card pop up in your Windows system, and you pick it and set your audio levels. The biggest issue you'll have is making sure all the menus are set right so that you're actually have told it to pull the audio from the internal sound card versus your microphone versus even you can have a sound card interface that goes in the back of the radio. In fact, I remember you used to go through that with your radio. Yeah, push to talk's going, nothing's going through it, no audio. Well, there was a menu setting in the Yaesu that you have to get exactly right to do that. So that's the easiest way to do it. If you can start with a rig that already has a sound card interface built into it, real simple and straightforward to get configured. The other way to go, where most of us had to go through prior to those rigs coming out with sound card interfaces, was what's called a sound card interface box. Personally, I've used the Signal Link for many years, and it's kind of funny to hear me say this. I won't ever buy another one again, not because they're not good equipment, but DRA, which is the Repeater Builders Group, they build a clearly superior product. The DRA50 sound card interface can go all the way up to 9600 baud. It doesn't use sound transformers in it, so you right out of the box can immediately go up to the highest speed by buying that interface, versus the Signal Links up until 2018 could only do 1200 baud. That's all they could do. After 2018, they put new audio transformers in them that do give a larger bandwidth, and I've used them. They're good. They're not as good as the DRA50. And when I'm in identical conditions with the two sitting side by side, all day long the DRA50 will outperform by about 20% on data transfer versus a Signal Link. And I believe it's because even though the audio transformer has been opened up for additional bandwidth, I don't think it's perfectly linear. I think there are some drop-offs as you go in the higher frequency, and it's just enough to drop the data rate down a little bit on VaraFM. So it's one of those deals. If you already have a Signal Link, go ahead and use it. You can run Vara Narrow, everything's great. If you already bought a Signal Link and it's got the new audio transformers, go ahead and use it. But if you have an opportunity, you haven't started with anything, I definitely, the Repeater Builder stuff's great. Go ahead.
What about software or sound card software like Direwolf?
Well, this is what I'll say to you on the whole thing. Like Direwolf. Direwolf is a packet radio program. So Direwolf, the most you're going to be able to do is 1200 baud, maybe 9600 baud if you set it up and run it through a sound card interface or what have you, but it's not going to be nearly as fast as VaraFM. So I'll be quite honest about it. If there's people around here that have interest in packet radio, I'll put a packet radio port back up on my system. I had it up for the better part of 3.5 years, in which I didn't have a single connect from anybody. So I finally said, okay, that's enough. I'll just shut the software down and move on. But if there's somebody that has an old packet TNC or wants to do that, that's great. But if you're starting from scratch, I say go straight to VaraFM, drive the Cadillac and go. There's no reason to go back to the past. Yes.
About Zimmerman, which is the manufacturing part of the computer building.
Yes.
Is also a lot cheaper.
Yes, it is.
A lot cheaper.
Yeah. Yeah, SignalLink is about $110, $120 with all the cables and everything. And I think he's selling for $55 right now, I think is what he's selling at. So yes, it is cheaper. The other thing about it, just talking about things in general, the repeater builder, this is just something for the long haul. The repeater builder setup does not use a mechanical relay. I've had to replace mechanical relays in the SignalLinks, but I'm also a heavy-duty user. On one of them that I used, I can't remember how I figured it out, but I went back and basically calculated that I had several 100,000 cycles on it, and the relay was starting to get sloppy on the whole thing, and all the SignalLinks have the mechanical relays in them. So that's another thing that he did, which was much better, and that is getting away from the mechanical relays. And by the way, that mechanical relay gets really annoying in the middle of the night when it's really quiet in the entire house, and all of a sudden you hear clickety-click, clickety-click going on there, you know, every time it goes to push to talk. Other questions?
Is something like a rig blaster in place?
Yes, you can definitely use the rig blasters as well. Yes, yes, yeah. But you can use a rig blaster is a good brand right there. And when you get up on HF, you're never going to run the 9600 baud, wide bandwidth right there, because if you do 12.5 kilohertz in the 80 meter band right there, you'll get banned for life. Nobody will like you. And the radios aren't capable of it anyway, but there are some people that I've seen that they sound like they're stereo up there that are running upwards of 5,000 hertz. I mean, I don't know how exactly. I mean, I guess the radios are capable, whatever, but they just huge bandwidth that they take up there. That's being a little bit obnoxious.
With this system, you would probably be better on VHF or UHF?
For speed, yes, absolutely.
And if you went to a repeater system,
Yes. You can go peer-to-peer with this. In fact, what's built in the software, normally it goes to a central messaging server. And I have a what's called RMS, which is passes you to the central messaging server at my house. So if you connect in my system, AE5ME-13, if you connect directly to me, you tunnel through the internet, go central messaging server, message goes out, everything's great. Then, if somebody sends a message back to you, you'll retrieve it and get it. Well, what happens if the internet goes down? What happens if the power goes out at my house? What happens if my generator dies? What have you? You can go straight to peer-to-peer, open a session with your friend right over there, go point to point, and send messages back and forth all day long. Yes. 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 Yeah, the one thing, and I love the fact that we do an NTS voice net, because the reality is the majority of the people besides me, I'm one of those weird people, I'm always going to have a laptop or something along with me anywhere that I go. As best I can tell, I don't think I've been without some type of device to type on for at least 15 years now. I'm the exception. If you're out there and this is all you've got, you're going to call somebody and give them an NTS message via voice. You have no other option. But I can tell you from experiences that we've had in the past, Paul's been through this before, where we've originated a message here and then we passed it through and maybe went through a few nets and then it got sent over to HF. And then we found out, I think this has got to be over 5 years ago, found out it didn't get delivered because a number got transposed or something happened along the way. And that can happen with voice communication. The other thing about it is your throughput is limited. I talk fast. if I slow down to the point to make sure that you get it exactly, I'm going to probably repeat myself 1 or 2 times as well. How long do you think it's going to take to send even just, let's say, an 18-word message?
Long time.
Take a minute or 2.
Makes 300 baud seem fast.
Yeah, exactly. I can tell you what we did one time just as an experiment to show the difference between the two was we had a station start with giving a voice NTS message, and then right beside him we sat there and took a bunch of NTS messages that we'd composed up, we copied them and said, okay, hit send and let's go. In the time it took to send the first message, which by the way our message was the same as the voice message, just to be fair on it there, in the time that message was sent, we sent 250 messages. So there's a 250 times difference that you can do throughput in this system. So that alone in a high traffic environment is going to give you a lot more bandwidth to get stuff in and out of the area, notwithstanding the fact that, by the way, you can use forms, which I had a few of them I pulled up here just to show you guys some stuff. Like here's an ICS 213 form. It opens it up in the web browser, and you can actually, this is viewing the form, but I can open up and compose a message and actually fill in all the blanks in this form. So I'm using a web browser form, filling out my ICS 213. It kind of prompts me for what I need to do. How would you do an ICS 213 via voice? I'm not exactly sure. I mean, we also have the all the other ICS forms. The only ICS form that's not in here is the one that's for planning of an event, because that one actually has room in it for graphics and some other stuff in there. But outside of that form, but outside of that, all the other ICS forms are available, your 213s and your 300 series. The ICS 309, for example. Really neat feature built in the software is when you're done with an event, you can actually take all the messages that are in there. You go up and say, create an ICS 309 form, and it actually goes through and looks at all the messages and fills your ICS 309 form out with call signs, time that the message was sent, all that information. So you're at the end of the event, your event report is very quick, very quick to file there.
And of course, I've got the history.
Yes. Yeah, that's the other thing is that during the event, as you can see right here, I've got all the messages that I've been sending. In fact, these were messages I sent to KI5DAZ back there during an actual event. And there's an ICS form that was actually sent to him. So if we have to ever go back and try to figure out what happened, because I can tell you every time that you have one of these training exercises, it's a learning experience. This is easy to go back and see, hey, where did things go off the rails? Well, Jeff was telling KI5DAZ that the train was on the west side of town and it was actually on the east side of town. Hey, by the way, it's in black and white. You can go back and find it, whereas when you're doing audio during a net, people hear different things and your reports may vary. So this gives you a real clear setup here to be able to do that type of stuff. I also can tell you served agencies like it as well from a legal perspective, because from their standpoint, if they ever do get into a liability issue, it's much easier for them to go back to the logs and figure things out. In fact, I had a conversation with a gentleman down in Florida, and that's exactly what happened after one of their events. They had unfortunately had during an event bad information get passed on that caused somebody to be put in peril. And the law enforcement agency that was involved with them was like, hey, we have to do an internal investigation. They pulled the information. Well, it was there versus he said, she said, what have you. And they were very thankful to have that information versus having the hard way to do it. Go ahead.
That happened to me in Missouri where I was emergency management director.
Yeah.
And we passed a message over WINLINK, and it did come in an error. We found out that the operator typing it into WINLINK added 3 zeros to a resource request.
Yep.
So instead of getting 5,000 bottles of water, we got 500,000.
Oh my gosh, yeah, that's a good time. Yep.
But we have a trail where we can look at and go, this is what happened.
This is where it came off the rails. This is what I need to do.
Is the log repeated through the various peers that it goes through?
Yes.
So that it doesn't repose in one spot.
Now, actually, if you use the gateway, and this is something I'll just have to tell you flat up, we put into place within the WINLINK system. If you go through a central messaging server, I see every message that goes through my gateway because technically I am responsible for the content that goes through there. I have had to have a conversation with a user that said that you can't ever send a message like that again over my gateway because there was objectionable content in the message right there. So all those messages, we keep a log within the WinLink servers. I personally, when they go through my server, I keep a log up to a year later just in case an issue comes up. And then, of course, whoever you send it to has it on their system. In this case where this user that was misusing the system was using it there, I contacted the person that they sent the message to and asked for a copy to be sent to me right there so I could approach them with it and just say, hey, look, we can't do that on amateur radio, because basically it was a commercial transaction being facilitated. And it wasn't to sell a radio, by the way. It was another commercial, and they just didn't think when they did the whole thing, but we don't want to get ourselves in trouble there.
What does it look like at the very end? What it looks like after you've done all this? What's it look like?
You mean the messages?
The message and everything else with it.
Yeah. Here's an example of some messages we were sending back and forth. You get it looks just like an email. You'll see all the text there. And then if I want to respond back to him, I can say reply. And it'll pop right up on my screen, and I can send a message to him right now after I've typed it in.
So the message ID is number 7, right? What do you say? You just go down 1, 2, 3, 4, 5, and then fill this in? Or
Just, yeah, I'll give you an idea. If I was going to fill out an ICS form, close anyway. So let's say I wanted to do an ICS form. New message. I select a template, and I say, hey, I want to use an ICS form. And ICS 213 is the one I really like. Okay, hit that, and a web browser will pop up. And there's the form. If I want to send a radiogram, I'll close out of this.
And that's the final page that you're going to see? Or
Yes.
Is it just loaded into the computer again?
Yes.
The key?
Yes.
And then you can print it, right?
Yep. So if I go radiogram, and by the way, it even has an ICS 213 radiogram, which is kind of neat. But there's a radiogram form, and you can see it even has a number in front of it, auto numbers. It tells you, it takes you right through how to fill out a radiogram. It even does the checksum for you. And when
More familiar than I'm.
yes, and when you receive a message that comes across there, you can pop it up so it'll actually come up in this form, and you can see it again. So.
Send the message right from the form?
Yes. Yeah, you fill out the entire form, and when you fill it out, what it actually does, which is kind of neat to save bandwidth, is it gets all the information from those various form entries, and it puts them in as an attachment to the actual message in XML. And so then all that information is there. Then when it goes to the other station, they say, oh, that's form such and such. They pull it from their library and then populate the form with all that. So you don't have to send the whole HTML form over. You aren't sending all the, let me put it this way. The PDF forms, they're great that ARL has put out there for all the various things. But if you ever send it as an email attachment, they're huge, So this allows you to save bandwidth. Go ahead.
I see no need for word count there. Has that been eliminated?
Well, it actually does word count there. So if you go in, I'll select that template, and we want to go to radiograms. So if you notice up here where the checksum is, I can't edit that. I can't do anything with it. But if I go down here and say, hello, Paul, notice my checksum just changed to 2 up there. So it does the count for you automatically. And by the way, you can select current UTC time or current local time. I guess we're at 20:07 Lima right now, but no, let's go to UTC. We can change that right on the fly there. And you notice the date just bumped out to the 19th because on UTC we're actually across to the 19th already tonight.
I thought I was getting tired.
Yeah, yeah.
I sleep on UTC time.
Yep. Other stuff that's available on it, and I am, no, I don't want to update that. Okay. It has a catalog for queries, and it has everything about like how to do things in WinLink, but it also has meteorological data. And if I go a little bit further down, it's got weather information for different areas. It's got NOAA weather satellite information. There are 2-line elements. U.S. coast information, which includes bulletins, as well as radar data. And it also even has a weather satellite picture, which I always forget where those are located at. Let me see if Atlantic has it. Yeah. There's the marine, it has tropical cyclone marine graphic. So if I hit post request right here, oops, I got to select a query.
It's aviation.
Yeah, if I hit post request, it actually put in my outbox a request to the server to send that GIF file to me. If I was connected to a radio, then I'd hit my send and receive, and I would be able to pull that information down. Something that W5ACR did the other night was he actually sent me a weather radar picture on my WinLink account right there, so I could pull it down and go with the whole thing. So you can send graphics back and forth, things like that, and that's where VaraFM becomes real powerful to do that, because if you're doing that at 1200 baud, it would just take forever.
The other advantage too with VaraFM is that any licensed amateur will be able to use it.
Yes. Yeah, anybody, regardless of privileges, they're going to have the privileges to do it on FM. Interestingly enough, there actually have been experiments on 6 meter FM, 440, 220, and I want to say somebody's even done a 900 megahertz experiment with it. So, like we were saying, regardless of amateur privileges, it's not just limited to 2 meter and 440. There's a lot of other bands that it's very well suited for.
So, I've got one of these at my house, and I decided to send a message. The message, if I want to send it to him, and he's not on,
Good question.
it goes away.
Yeah.
But if it goes through your server,
Yes.
your server saves it and continues
To pass it on, yes.
to pass it on.
Yeah, so for example, and this is the rules of the road, the good thing about WinLink is not only can you send messages to other hams, but you can also send messages to anybody with an email address. So you type it up in there, and like for example, I think I even have some I sent email box. Let me see here. Yeah, AE5ME at yahoo.com. I actually sent a message to myself as a test. So you can send a message to somebody else who's a non-ham, send it to them. And what that also does at that point is opens up what's called the whitelist. And at that point, they can send a message back to you, because at this point you've approved them. You've said, hey, this is somebody I know, they're okay. But if you never sent the message to them, you won't get spammed back with a bunch of stuff from people that just create stuff there. You have to initiate the contact first to do it. Add it to your whitelist. So
Right now in this area, you've got the only server.
yes, that is correct.
Could be other
Yeah.
servers out
In Oklahoma as a whole right now, I have the only HF server for the state of Oklahoma, but I can tell you right now in HF, you'll have no problem hitting any of the Arkansas servers, North Texas, any of the Kansas servers, so that's not bad at all. There are some servers, by the way, on 20 meters, so you can hit Illinois all the way up the East Coast and what have you like that through those. I was the only VHF server for quite some time, but since late breaking news on that, we have 2 other VHF stations that have opened up around the Oklahoma City area that are operating as gateways as well, and they're running VaraFM. And then I also opened up in Fort Gibson the AE5ME-14 gateway, which allows you to connect in there, and it's got excellent coverage. It covers this area very well right there. It's basically in the same location as the 147.33 repeater, so if you can hit 3.3 repeater, you can hit the gateway.
I used to connect into you all the time from Missouri.
Yeah. Yep. Yeah, I had quite a few people from Missouri. Arkansas was another area that we had quite a bit of people connecting in, and it's always fun to see it when it happens right there. See the new station that decides to connect up and see what they're looking at and everything else and what they're downloading. And of course, the real horror story, I'm going to pick on you right there, is you take a few months away from pulling messages, and all of a sudden I look up there and it's like, oh, you have 26 messages, and it's just going through there, cycling through. So it does pay to check your messages often versus making a big sabbatical between them.
I'm guilty.
Yep. Yeah, people have done that. Something I'll show you here. Let's see if there it is. So you want to get started on this and you don't know where to start. there's a address here that Paul didn't even know about that was called ok.arl.org. I still remember the night that I told him about that, and he's like, oh, that's neat. If you go up to it, there's a section on it called National Traffic System Oklahoma, NTSOK, software installation. And it basically takes you through step by step, how do I install the software? This is where I go, this is how I install it, how I unzip it, fixing any of the font issues that you may run into. Where do I get VaraHF from? Where do I get VaraVHF from? How do I install it? What does it look like after it's been installed? How do I get a registration key? How do I back up my information so that if my computer ever crashes? And so this is an excellent, and then how do I send up a tactical email account, which you would typically use for special events, where you want to have a tactical call sign that you're sitting there sending messages to, so it's not just you, but it's comm officer or whatever is the name of the tactical call sign. In Oklahoma, for example, we have NTSOK, NTSOK CAP, NTSOK, and all the districts as well there. And so we have tactical addresses set up on those of us that participate in the NTS system. We actually have all that information programmed into our deals. So for example, if you send to NTSOK-DIST07, I get it. I get that message, and then I'll turn around and pass it to NTSOK, which is our central repository, and then he'll pass it outside of the area to the appropriate NTS.
VaraFM discussed on that site?
Yes. Talks about how to set up, how to choose HF channel when you're operating a channel. One of the neat things about the software is you actually download you download all the information about the stations, and then it will actually do a reliability estimate, which is very accurate. Amazingly so, every time I've opened up my laptop in the middle of my house, the AE5ME-13 shows up with reliability path of 100%. I don't know why that is there, you know. And literally what's funny about it is distance mile goes 0, which is really hilarious. But you'll see, like, I'm a really good path here, but let's say I'm busy or things are going on, you'll see KB5LZK is a very good path. He's out of Arkansas. K0SI, very good path. KC5GOI, very good path. 85EO, he's my secondary Arkansas guy I connect to. All the way down to K0ISP, which I believe is up in Missouri, KD0SFY, which I believe is up there, and then K9BBS, which is actually up in Illinois. So there's plenty of HF stations to connect to if you need to get on through. The way my HF station works, which is typical of most HF stations, is I actually scan 2 different channels, 80 meter, 40 meter, 80 meter, 40 meter. So like during the day, 40 meters is pretty cool, 80 meters not so much, but at night, 40 meters kind of goes away, and 80 meters becomes the primary place to go there. Now, mileage varies, and that's the reason I scan, because some days 80 meters is open all day long, great, and other times 80 meters isn't open at night, so you may have to use 40 meter to get in or what have you, but you have your options. So
one thing you brought up at the Bartico meeting was there is a free license to this.
Yes.
But it's slowed down, and it's really for evaluation purposes. So
yes,
if you want to try it, you don't have to pay the licensing fee to try it.
That's right. You can download it for free, and you're at the lowest speed, but you can still test it, get everything put together, and go through the whole thing. I think that's the way you got started up, was the free copy there. If you want to learn more about what is WinLink, how does it work, this is once again on the okarl.org website. These common messaging servers, the central messaging servers, which run on the Amazon cloud, the RMS gateways, which are what I operate, and then of course the individual stations that are out in the field connecting in. And what's really funny about it, you have to, this is what's happened. In the graphic they call them the common messaging servers, and then they go down here and talk about the content messaging servers, and then if you read other literature, it's the central messaging servers. So everybody's called them a different thing over a period of time, but then you have all the hardware requirements that are required, and then if you want to know how to connect in, by the way, this just changed as of tonight. AE5ME-13 and 14 have now moved to 145.03 because we finally got the radio down in Fort Gibson reprogrammed. I literally was driving over here, and Nathan texted me, he said, hey, I got it reprogrammed. So, but you'll notice that we also have a VaraFM digipeater. Why do we have a digipeater set up? If we ever lose internet down at Fort Gibson, you can go right through the digipeater and connect to my station in Broken Arrow. So now we have full redundancy so that if the internet goes down there or the internet goes down at my place, one way or another, you can get to a gateway that will get you into the central messaging servers. There's also W5LHG that's in Blanchard, and also N0LOZ-10, which is in Prague. And there's talk about a gateway in Vian, Guthrie, East Norman, and northeastern Oklahoma City coming online. Huh?
What could we reach from here?
Fort Gibson. Fort Gibson. It would be very difficult to hit the Blanchard one, and Prague would be very difficult to hit from here unless you've got like a 200-foot tower and a beam antenna. Yeah, you'd need major altitude, but the Fort Gibson is the best one to hit from here. In the Tulsa metro area, you'll have to run the full 50 watts to get to it. Yeah, yeah. Now, if you happen to live in Broken Arrow and right near 101st and Garnett, my station right there is really easy to hit, but I'm also only running on a 20-foot antenna on that whole thing, so it's not got high elevation at all on that particular setup. Yeah.
Okay. That's the problem with putting it out of sight. So that's the first question I'm going to get asked. Well, why don't we put one of these up?
Yeah.
All these codecs into open source.
Yes. That's been a discussion. Yeah. Yeah. What I can tell you is the way we operate Fort Gibson, which isn't always the way everybody's operated, is we have full internet service there, so we can remote into the, and we actually run, if you guys have seen my Facebook post there, we run a compute stick that's literally that long and that wide is all we run down there for the whole thing. And I only run the VaraFM software and then the gateway software. That's all I run on it. I don't clutter it with a bunch of stuff, and it's been very stable there as far as the operations concerned. If you're running a site that doesn't have internet service, you definitely are going to want something that has what I call a pacemaker software on it, and that is what it'll do is it'll check every so often. If it sees something hung on a software, it'll reboot the whole system and bring it back up. Or in some cases, what I've done is said, you know what, every morning at 2 o'clock in the morning, go through your reboot sequence there. The other thing that I've done at those sites is typically if they're co-located with another repeater, I'll put a relay on that repeater that I can control via DTMF or something, power cycle the computer to bring it back up, because 9 times out of 10 if you power cycle it, you will be able to get it back up and get it working again right there. But Bob's exactly right. I'd love to have it over in Linux. It'd be great to have it on a Raspberry Pi.
So one thing I'll tell everyone about is there's a company, and it's not outstanding, but there's a device called Power USB is the manufacturer. And you can get a small Linux platform like a Raspberry Pi that you can plug via USB into the Power USB. Basically, it's just a switching power strip. And so you can have permanently on ports and you can have controlled ports. And the main deal is that if you put your little Raspberry Pi there and have an internet connection to it, then you can connect to your Raspberry Pi and power cycle things.
Yep.
And so that would be one of the ways to fix remote Windows stuff when it's hung and you can't get to it. If you just need, because Windows halts in the middle of updates
and everything else.
dies for random reasons. And in Windows 10 initially, there are all kinds of things that would happen when updates were pending. It would turn off internet connections. It would stop allowing incoming connections. It would do all kinds of weird stuff. So if you go look, if you really want to do Windows things like this remotely, look at something like Power USB. There's other things like it, but it's not very expensive. It's about $120 to have that device, and then you can do some stuff. And come talk to me because I've rewritten their software so that it's much better behaved on Linux.
Yep. Here is, in case you guys happen to be listening on your radio sometime on 145.01 or 03, this is typically what, hear that? That's what VAR sounds like when it's trying to dial out. So if you start, Yeah. So if you hear that coming up, ringing telephone, yeah. So if you hear that going out over the air, that's actually it trying to make a connection someplace else. And then you'll hear various back and forth data type stuff going on in the whole thing. So that covers that. When do you have to be out of here, by 8:30 or 9 o'clock?
Oh, we're about 23 minutes over.
Are we 23 minutes over? Then I will make this very quick. I will flash through a bunch of stuff on the screen really quick here. Just wanted to share with the group, because you're asking, hey, what else do we do here that's digital as well? You know, we talk a lot about WinLink and everything. This is the dashboard. And how many people play with Pi-Star at all? Pi-Star and their little, so we have a big Pi-Star node up at the 44435 repeater over in Claremore. So it has what's called an MMDVM board, but it actually goes to a full power repeater. So with that, if you look over on the side, the modes that are enabled, you can run D-Star, DMR, Yaesu System Fusion, P25, NXDN I typically leave off because nobody has an NXDN radio here, so I just took it out of the scan sequence right there. But what that means is this particular repeater, it has a split personality. You can run Yaesu System Fusion most of the time, but if you have a D-Star radio, you can talk into it, connect to your talk groups of choice. If you got a P25 radio, you can do the same thing right there. The repeater is fully good to talk in many, many, many different modes out there. In fact, I kind of was impressed tonight. I brought my Yaesu System Fusion radio with me here. And I'm keying it down. We should pop up here in a second. Well, there it is. You'll notice, and I had a really high bit error rate because we're in a building there, but point is, it went to the Yaesu System Fusion mode, and that's how it operated right there. But if I picked up a D-Star radio, did the same thing. If I picked up a DMR radio, I can do the same thing. If I picked up a P25 radio. Monday nights, we carry the statewide 3140 AriesNet on this in native DMR. If you have it in your code plug, you can go right over to our repeater and listen in just like anybody else does there. Along with that is what's called the Oklahoma Link system. This is the YSF reflector portion of it. There is also an XLX reflector that is connected to it. So in addition to being able to do all those modes on the repeater that I talked about, we now have reflectors that are all tied in the system that can do multiple modes as well, which means if you're on another repeater, you can operate on another mode and talk to your friend on this repeater in whatever mode that you would like to be on. So the example that I'll give right here is you guys have the 443 repeater over here that's on Yaesu System Fusion. I can pick up my radio right now on Yaesu System Fusion, key up and talk, and I could have somebody running on D-Star up at 44435 up there and talk back and forth just like you were, same radios going between there. So when people kind of get into digital radios, they're like, well, if I pick the wrong radio, I won't be able to talk to anybody. No, you'll be able to talk to somebody because we found a way to do it type thing. So that's our multi-protocol reflector. And in addition to that, All-Star over on the 14709 repeater has the capability to be bridged on request over to it as well. So if an emergency came up and we need to have the digital guys talking to the analog guys, we have the ability to actually go over to our All-Star boredom breaker hub and be able to directly connect in and carry traffic between the two systems as well. So a lot of times I use it as a demonstration for people who have an analog radio, and it's like, well, what's digital all about? Well, listen to our net on Monday nights and you'll find out what digital is all about and talk to the people that have digital radios. In addition to all of this, something I've been talking about quite a bit, and it's a whole presentation for a later time, M17. Yes, it's a new gang. We have special symbols that we do for right there. You have to have a call sign that has engineer in it someplace right there because you have to be a geek. That's the way it works. But M17 is a new protocol that's being developed. All of these radios, everything, and Greg's been through this, so he knows about every one of these radios has a licensed chip in it that's made by, was it VLSI is the name of the company, I believe? DVSI. So every time you buy one of these radios, you pay a certain amount of money to them. You have to have the special chip. You got to have all this stuff if you want to do any of this type of stuff. And so it's a very proprietary type setup. And by the way, you know, D-Star's got their way with certain chips, and then everybody else has the other chips that they use and stuff. M17 is a complete open source protocol from the base, including the codec. So codec 2 is what it uses, totally open source, and the modulation scheme is open source. So the idea is if we develop this, then you get away from having a proprietary technology that's connected in with one company and it's all closed source and everything else, and you have the ability now to run open source and produce radios that will be able to do this type of stuff. It's very much in its infancy. This reflector has had 4 revisions just since I've put it up on their whole thing, because we learn new stuff as we're doing this. But there's a group of us that are actually putting together, making M17 radios here locally, that are doing them by modifying the MD380 handy talkie that can be modified to do M17. We're also going to actually build some radios using the MMDVM boards as well, because it can be set up to do M17. The point is, there's some neat stuff coming around the corner with M17, and one of the things that will come with this is combination voice and data simultaneously on the same channel setup. With adjustable bandwidth. So think about this. This is the dream we all have. And by the way, when I say this, it may be 5 or 10 years before we get there. But the dream I have is be out there with your handy talkie, have it linked into your computer, and while you're sitting there talking to your friend about the storm that's going on, they're sending you a WinLink message across there that has the radar that you can look at, and you can put it all together. And that,
every bit of silence is
yeah, exactly. And then you send them back the picture of the storm right there and show just how bad it is. Meanwhile, you guys are still chit-chatting back and forth on the digital side. That's what M17 is going to be able to give us for moving into the future. But if you get a chance, check it out. There is a piece of software called DroidStar, and you can load it up on your tablet of choice, and you can connect into the M17 reflector. And in fact, the other night, I've actually used it since then, but the other night I actually checked into our Oklahoma Link net through M17 using my DroidStar setup right there. So it was our first ever check into a net via M17. And
go to the M17 website, you can sign up to participate. They're looking for people to help.
Yes.
All kinds of things.
Yeah. And
Technical, hardware technical.
Yeah.
All kinds of things.
Yeah, and by the way, the Amateur Radio Digital Foundation donated $250,000 to develop the technology. So this is for real. This isn't just a bunch of guys sitting around, dreaming on that and everything else. And that also leads me to Robert Stratton said at the last meeting that was over in Norman, coming up this April, you'll actually be able to apply for club funding, and I can't remember the total amount. I think they gave $500,000 for that, was what ARDF gave to it. But basically, if you've got a project that you'd like to do, turn it in, see if they can get to fund it, and it'd be a great opportunity to get things kicked off. So, do something similar to this.
You can do up to $25,000.
Yep, $25,000. So it'd be.
Is that the M17 website?
No, the M17 website is called Project M17. If you go up to Google and type in Project M17, it'll take you straight to the website. This is actually our reflector dashboard.
Okay, thank you.
Yeah.